All right, everyone. This is the second part of today's this week's lecture, week one. As I said, what I'm thinking I'm going to do is just meet everyone for 1 hour or whatever it is, 2:15 to 3:15 on Wednesdays, and just continue it. Have the next module to be asynchronous. So if we meet on Wednesdays between 3:15 and 4:15, that means I can give you some more offline content at every week, and have your in-class assignment due based on that offline content, and then have another, I want to say weekend assignment, but we'll call it a weekly assignment that would be due that Wednesday. So, anyways, we'll just do something really easy this week, and then we can focus on more complex things, in the next coming weeks. So here we have this. Moving on in this next slide right here. As I said, we're just showing how exactly, if you did not use an IDE, how exactly would you compile it using the terminal. So here I am with the Unix terminal or on a MacBook, and we have, now notice the name of this, and I'm just gonna break with this, and then the name of this is Hello World 5. Okay, so if I did an ls and then I did a grep for the number 5, we can see that there is a there is that mistaken one I did the other day. So I'm going to go ahead and remove this, and let's go ahead and list and filter. That's what the grep does. It essentially filters for every file name with the word 5 in here. And if we just did an ls, we can see all the other file names right here. So this is just Hello World 5, and let's edit that Hello World 5 program, and we can see that this won't fly if I go ahead and, even though everything is syntactically correct, can you hopefully see what the problem is? And you should see that the name of the file is Hello World 5. So let's attempt to compile it, and then you'll see what the issue is. So to compile this, we'll say Java C or Java compiler, and we'll get an error. Oh, we do not get an error. You'd think we would get an error. So let's go ahead and run this. Let's go ahead and run this. And look at that. That is the error. So the compiler did not catch that error, but it did catch the error that it could not find or load class Hello World 5. Because the reason why this is a problem is because the main method right here, which is, as I said, is very, very special. It is the ignition for the program. So the class that contains the main program, the main method, the class has to be the same name as the given file name, which is Hello World 5. This is Hello World 4. So let's change that to Hello World 5. And let's quit it, and let's compile it. And there should be no compiling issues. And here we go. It was able to compile and execute itself quite flawlessly. So the main point of this is that whatever file holds the main method, and let me draw a circle around here. Whatever file contains the main method, whatever class contains it, has to be the same name as the actual program. My first Java program.java, my first Java program right here, because we have to call that because, of course, that this class contains the main method right here, and that is very, very important. Okay, and let me erase this. And just so that you know, then is once we have everything correct in our program, we then compile it with the Java C command, and then of course we want to make sure that we refer to the proper file and make sure the spelling is correct, and make sure we include the extension right here, and then when we run it, we just say Java, not Java C, Java, and then we run the program. But notice there's no need to use the Java extension. All right. Now, how the Java code is executed. We begin with the text file, like in Notepad. Now, this is if you're doing it in terminal. Okay, so we create the Java file. We run it through the Java compile with the Java command, Java C command, right here, Java C. And that kind of goes back to this right here. And that turns that into bytecode, which is a .class program, .class extension. Now notice, if we run the list command and we filter or grep for every program with the number 5 in it, you'll see that there are two programs, Hello World 5.class and Hello World 5.java. So that's what it does. When it compiles, it creates the Hello World 5.class. Okay, and this is actually bytecode. So if we said Hello World 5.class, it's going to be a bunch of gobbledygook, as we can say. And Java's magic is Java's magic is in fact the bytecode. So even though it's garbage, it's gobbledygook, it actually is pretty powerful, because you can take that bytecode and then put it through what they call an interpreter, or the Java virtual machine. Now, Java virtual machine or interpreters are those, if you've ever had Windows and you just downloaded Java, not the language itself, but the program Java, the coffee cup always comes up. That gives us the ability to take the bytecode that was created when we compiled the code from the terminal. It's able to take the bytecode, put it through an interpreter, and allow it to be utilized by each of these proprietary systems. So the compiled code, which is what this is, the bytecode, in fact, is platform independent. So this bytecode is platform independent. So you can take this bytecode as on its own and literally run it through the Java virtual machine or interpreter, and it would create a Java program for each of these. So if you take the bytecode and put it through the Java virtual machine for Mac OS, you can run it on Mac OS. If you do the same for Solaris, which is nothing, Solaris was the Sun Microsystems distribution or flavor of Unix. And it was like one of the first flavors of. It was basically, Solaris was one of the first marketable versions of Unix, and Solaris they got into the big three, all these enterprises, to hold their data, to hold all their information, to be essentially its own platform. And then we all know the story of Win32. And what I'm saying is that the interpreter enables the same bytecode to be run on the Win32 kernel, the Unix kernel with Solaris, and the Unix kernel with Mac OS. So we have the Java runtime environment. So It goes from bytecode to the Java virtual machine. Now, the Java virtual machine allows Java to be portable, object oriented. It is object oriented, robust, and of course, both C Sharp and Python do have a similar architecture, which is why they're also platform independent. Interesting facts. Java itself was developed by James Gosling in 1995, and he always worked by this huge oak tree. So he initially called it Oak, then Green, and then it was renamed Java. Okay. Now, when it was, as I said, James Gosling was at Sun Microsystems before Sun was acquired by, as you can see here, it was acquired by Oracle, causing Gosling to leave, because what happens is when you have these small startups, they have like this rebellious attitude, forget the man, and all that, and then suddenly when you're bought out by big business, then all of a sudden, you start to you have to follow some procedures that you didn't want to before. You start to feel controlled, and also, Oracle had this huge beef with Microsoft because Microsoft's .NET platform was only working, for Microsoft, and the Java platform was always known for, interoperability between multiple systems. And then when .NET was able to work with Linux and Unix, Oracle tried to sue Microsoft, and then Microsoft won. But anyways, there was a huge legal thing, and a lot of people just don't like to be a part of it. Anyways, we have the different editions: Java, the Standard Edition, Enterprise Edition, and all that. So we're just going to stick with the Standard Edition. More interesting facts about Java: there are a huge amount of developers, and the one aspect of Java is it is closely associated with the idea of IoT, Internet of Things. So, in other words, formerly inanimate objects, that were just standalone, now have IP addresses, and now they can connect to some sort of remote server. And this is useful because, for example, let's say you had a IoT lamp, a smart lamp, let's say. So it's going to respond to network time protocols, and it's going to turn on and off as as the dusk rolls in. Imagine if you had a lamp that was able to, behave according to its environment. That is kind of interesting, but I don't want to. This is not as compelling as if we were in person. So I'm just gonna trust that you'll know what I'm talking about. Let's say you have window treatments or blinds on your windows that were smart blinds. Maybe they can connect with some sort of weather app, and the weather apps would say, "Hey, if it's really sunny, it's going to close your blinds. If it's cloudy, it may open them." Okay, if this is making sense. Smart TVs, smart refrigerators that can alert you if you're running low on milk and things like that. So Java is right smack in the middle of that. 3 billion mobile phones run Java, 120 million TV sets in every Blu-ray player. Average developer salary, $102,000. Keep in mind that's average. So that means you have just as many people making 40 or 50 as you do making, say, 200,000. What I'm saying is that it won't hurt you to know Java. Now, if you really want to get a job in the Java programming field, you are going to have to, align yourself with personal projects. You're going to have to align yourself with knowing, other things besides Java, such as networking and security. Now, Java is denoted by some of the there are basically three aspects of object-oriented protocols, or object-oriented programming, I should say, OOP. Okay, and I say it was noted that this is object-oriented. So, object-oriented programming is basically three things. It is encapsulation. Okay, I'll just put ENC. We have inheritance. I'll just say INH here. And the other aspect is polymorphism, and I will put it here. So those are some of the tenets of object-oriented programming. Okay, so encapsulation allows us to define the access of data fields, or what we call instance variables. So the two most popular ones are, I'll just say public, or PU, private, or PR, and then there is protected. Okay, and we probably won't even get to that, but the two main ones are going to be public and private. So private allows you to close off the access to either a method or class, or anything, or an instance variable. It allows you to close it off by anybody outside of that structure. Now, the point of that is, let's say we had, I always use this, the idea of the ATM, the bank ATM. You walk up to it and you can view, your bank account, but you cannot edit it. Imagine how awesome it would be if we could just edit the amount in our own bank account. So if we need, if we want to go to Vegas for the weekend, we want a couple grand, just pop into, just say 2000, and you're good to go. Unfortunately, life does not work that way. Inheritance is the idea where you have the attributes that would create an animal, but let's just take a look at canine. A canine, okay, can be described with certain things, like the amount of teeth it may have, how it hunts, how it communicates, how it sustains itself, how bloodthirsty it is. Like, for example, in terms of animals and mammals, polar bears. If you see a polar bear, you better run, because a polar bear is a trained killer, as an example. Whereas black bears and brown bears are also rough, but they may not. Black bears may not be quite as bad as polar bears, but I'm just saying their severity. So you can describe a canine in terms of the breed, in terms of this, in terms of that. So look at the retriever and poodle, okay? And then there's two I'm going to say subsets of retrievers, subclasses. That would be Labrador and Labrador Retriever and a Golden Retriever, okay? And so there might be different types of canine, like wolf, for example. So I'm just saying, it's the whole point. Now, what does inheritance have to do with programming? So we all know that a class is nothing more than, I'm going to say instance variables, or IVs. And then we have methods right here. I'll just say methods. And so if you create an instance variable for, let's say, canine, okay, and then you want to go ahead and create another subclass for retriever or Labrador, okay, you can just worry about the things that are different between a Labrador and Golden. You don't have to recreate the entire instance variables and methods of a canine. So in this next slide is a decent example. So here we have an animal, and an animal can be described. These are the instance variables, and these are the methods. Okay, so We can describe an animal or give it instance variables like with a picture, food, whether or not it's hungry is probably a Boolean value, its location, and then here's the things it can do: make noise, eat, sleep, and roam. Now, if you, let's say you wanted to instantiate and create a class for dog, okay, you can then draw from this if you choose or not. But even if you don't, when you create the subclass of dog from animal, you're also naturally inheriting all these. You actually have access to all these through inheritance. Now, polymorphism is different. So let's say, you know, let's say you have a let's say you have a class called runner. Okay, and let's say by default the parent class, has the word train. Now you could have, and that's a method. That's an action. You could have a subclass of runner called 4K runner. Now the 4K runner, you can also have another method called train, but this generic runner is going to be doing training one way. Now this 4K runner is going to train another way. So that's called polymorphism, when you have the same name of a method, but yet the definition of that method is different. Okay, that's called polymorphism. So animal is going to have like a make sound method. Now class dog is going to have, they're going to make sound one way, rough, 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 and a make sound method for cat, they're going to say meow. Okay, that's what we call polymorphism. Finally, we only have just a couple more slides. Here's our first program. We have system out print line I rule, system out print line the world. You notice that there's a natural line skipping right here because the print line. So try out print and print line, and you'll see the difference when you go ahead and program on your own. And another simple program, okay? And this is a comment right here. This is a comment, okay? Your program begins with a call to main, and that's with all programs. This is a one-line comment, and this is a multi-line comment. So if you want to have more than one line in a comment, there's your way to go. If you want to have one line, you do the double /. Here's another example in which we declare num as an integer. As it says, this declares a variable called num as an integer. Num equals 100. This assigns. So this is an assignment statement. And then we say system.out_println. This is num. And then notice that we created this this plus sign. This is called concatenation or something like that. So so the plus sign does two things. Okay, if we take two strings, say 4 plus 8 as strings, it's going to yield 48. But if we remove the strings, it's going to say 12, because the plus sign can either be a summation or concatenation depending on the objects that were given. So this operator can do different things based on the based on the operands. Okay, and yet this is an example, believe it or not, of polymorphism, because the plus sign remains the same, but it does different things based on the context that of its input. So if the input for this operand, or if the operands are strings, this will concatenate. If the strings are just numbers or integers, it will sum. Now keep in mind, it's the same operator. The only difference was the operands. Okay, and it will say, now this actually will multiply 100 times 2. Okay, however, if we said something like, and let's do this text box. If we said like star multiplied by 3, that's going to give us star, star, star. This is what we call, and I'm just going to pretend this is a comment. This is what we call replication. Okay, so if we said asterisk multiplied by 3, that's going to give us 3 asterisks. That's what we call replication. Okay, and actually we can do that right here. Let's go back and let's do Java, and let's do something like let's do string. Let's do string p equals p. Okay, and we could do system.out.print line and just say p multiplied by 3. And let's right quit this. And let's compile it. And it did not like that. What is going on here? Second type. It didn't like that. Let me see. P equals P. P times 3. It didn't like it. Let's do P plus 3. And let's run it. Okay, so it just says P3. Okay? Anyways. So, but however, if we did, it's supposed to say replication.